All right, guys, so these are two from section 2.4b, which for everybody, regardless of what teacher you had, um, it was on parallel and perpendicular lines for the most part. So we are going to discuss those, and what I do is I take questions really similar to your test and also off the homework, so it doesn't matter which teacher you had. Michener's was Delta Math on this topic, Miss Cedarholm's was bookwork on this topic, and Miss Peterson's was a blue worksheet on this topic. But they all asked about parallel and perpendicular lines. So first up, it just asked for the slope. When lines are parallel, the actual symbol in math for parallel lines are two lines that look like this. So when you see this symbol in geometry, they used to say L, this, and then N. It means line L is parallel to line N. And you'll notice they have the exact same steepness. Like if you were to drive up this one on your car, isn't that pretty, guys? Aren't I a good driver? And that one on your car, right? They have the exact same steepness or slope. So parallel lines have the same slope. So whenever it asks you for the slope of a line parallel, you just need to find the slope of one of them. Like if this slope was 2, you steal it for parallel lines because they have to have the same steepness or they'll cross. But remember, for you to find the slope, you have to solve it for y first. And those of you who were in here yesterday who are at home today, we talked about how you always get rid of the x term, not by multiplying or dividing, but by adding or subtracting, depending on whether it's positive or negative. So we got 4y equals, and yesterday I told you guys who are at home that sometimes it's easier to write this by adding them up instead of down. Like instead of saying 8 minus 2x, or like 5 plus 3, saying 3 plus 5 with these, because it gets them in the right form without you having to move things around. Then we always end by dividing by what's in the way, and you divide by everything by what's in the way of the y. So they always, when you solve for y, get rid of the x term by either adding or subtracting. Again, had that been a negative 2x, you would have added it. You do the opposite. Then you always get rid of what's in front of the y by dividing everything. It'll fall into slope intercept form. Negative 2 over 4 is negative 1/2 x, and then 8 over 4 is 2. So you guys in here, what is the slope of this line? Go ahead and tell me, Rhea, what's the slope of that line? Y equals negative 1/2 x plus 2. What's its slope? That's the y-intercept. So what's in front of the x is always the slope. It's y equals slope x is really what it is. They call it mx, but it's the slope. So the slope is negative 1/2. This guy over here is the y-intercept. The y-intercept doesn't affect the steepness of the hill. It just tells me when that line's going to hit the y-axis, but that doesn't affect how steep it's going, right, Leah? It's this right here that affects it. So because it said parallel, we steal the slope. So you find the slope and you steal it, and you always run parallel. Does that make sense? Yesterday, some of the kids were doing a graphing on Delta Math, and they had to graph this line. So let's just review that. Remember, it's y equals mx plus b. This is the y-intercept, and this is the slope. So you always hop on your y-axis, and you put a dot there. For this one, it'd be a dot at 2. Does that make sense? And then your slope tells you what to do from there. One of the biggest mistakes I see with these is kids will slope it out from the origin. You have to slope it out from your y-intercept. Because it's negative, you'll fall, and then you'll run 2 to the right. This is the line. Any line with the same slope will run parallel. So watch, Connor. If I said y equals negative 1/2 x, steal that slope, and then do minus 3, it would be down here. But I'd still go down 1 over 2. So it will run parallel. Because, whoops, let's make the dot bigger because I missed it. Right? So when it says parallel, steal the slope. Got it? And it has to be y equals. When it says perpendicular, well, those don't have the same slopes. Perpendicular means that they hit at right angles, so you can't steal the slope. But this is how they're related. If this was up 3 over 5, this goes down 5 over 3. What's the relationship between them if they're perpendicular? What do you think? Go ahead, tell me one of you guys. They can't hear you, but I can. If they're perpendicular and I said this is the, oops. If I said that this one, if it was 3/5, the one perpendicular would be -5/3. What do you think I'm going to tell you to do with those slopes? Flip them and do what? Because they're not just flipped. If one goes uphill, the other has to go down for them to meet like this. So if one of them's positive, what does the other have to be? Negative. So you not only flip, so let's write that you're right, you flip it, but then you also take the opposite. So I say opposite flip. But again, Rhea, before you can do that, you have to solve it for y. And yesterday, remember what we said, those of you at home, you always get rid of the x term by adding or subtracting. You do the opposite of what's there. It gives you far y equals. And remember I told you guys yesterday to add up the screen. I would do it like that, so it's in y equals mx plus b form. And then Shay, what will I do to solve this one for y? Always, you divide by what's in the way. If this had been a -4, you divide by a negative. So we're going to do 4, 4, 4. If it had said parallel, I'd grab this slope, and that would be my answer. But it said perpendicular, Rhea, so I need to flip it, right? And take the opposite. So to be perpendicular, Connor, what would my slope have to be? -4/3. Does that make sense, Leah? Parallel, steal it. Perpendicular, flip, and take the opposite. So the other type of question that's worth quite a bit actually on this chapter when you get tested, this is a big question. So make sure when it says write an equation for a line that you have an equation. Make sure you read whether it's parallel, steal the slope, or perpendicular, flip it and take the opposite. And then also make sure you leave it in the right form. So this is a great problem for reviewing 2.3 as well. So if I need to run parallel and it's already solved for y, that's kind of nice, right? Because what's the slope? What's the slope of this line right here? Y equals 3x minus 5 has a slope of 3, exactly. Am I going to steal it or am I going to flip it and take the opposite? Steal it. Yep, if you run parallel, you have the same slope. So my slope is 3. If it had said perpendicular, I'd flip it and take the opposite. Right, Rhea? So the slope is 3, and they're telling me a point. Those of you here yesterday when we talked about 2.3, I said to call this point that you know, the x you know, and the y you know. And then for point slope form, you need a point, got it. And you need the slope, stole it. And then you always go y minus the y you know, 5, is equal to the slope, stole it, times x minus the x you know. Now some of you were getting red x's yesterday on Delta Math because you were saying x minus 1 for one like this. So make sure if you're doing Michener's Delta Math, it's x minus a -1. So you'll notice you end up having sort of the opposite signs of the actual point. Did that happen to you a couple times or no? Did that make sense, Connor? And the only difference, Shay, that there'd be if this had said perpendicular is we wouldn't have stole the slope. We would have flipped it and made it opposite. What do you think? All right. So those of you with Miss Peterson, I want you working, is that just you or you two? Both of you, you should be working on a blue worksheet that's on parallel perpendicular lines. Michener's Delta Math on parallel perpendicular lines. And Miss Cedarholm's bookwork. And I think I'm going to focus on Miss Cedarholm's bookwork next. I'm going to do a couple with those who have her. So if you have Miss Cedarholm, or if you still want more examples, hang on with me. We're going to grab Leah's assignment. I'm going to pick a couple she hasn't done yet to do. So those of you on, what day is it today? Is it A day? My B day and my distance learners, if you have book work, hang with me. We're going to go do a couple. I'm going to go just run and take a look at Leah's assignment. Do you have it written down? Perfect. It looks like you did. Is that today's? Yeah. So, oh, the one before this. This was yesterday's is the one.
No, this is
Okay, I want yesterday's. Do you have it written down somewhere for me? Thank you, dear. Again, we'll be looking at the 1-4, not the linear regression. Actually, if you have questions on that, I would just watch the notes from your teacher because I wouldn't say anything. I can't really even shorten it up. So they tell you how to use the calculator and all that good stuff. But I will go steal while Leah's looking at the assignment. Those of you who have a book assignment, we will go do, let's say, 2 different kinds. And I think it'll be Did you find it, huh? 2.4, yeah. Yes.
Yeah, it's pages 86 through 88.
Okay.
And then it's 18, 20, 31 odd, 36 through 45.
Okay. Thanks. That is not the parallel perpendicular stuff, but I'm going to do one of those anyway. Okay? I heard you say 18, so I'm going to hit 18 just to get people started. Alright, and this is on the 2.4 book assignment, page 86. It said, write in point slope form an equation that goes through. Now, if you were with me yesterday, I actually think I did this with Jackson, but that's okay. And number 18 was -6, 15. It said, Leah, to do point slope form. So you need a point, which you have. You actually have too many points. You have 2 of them, right? So I'm just going to grab one. It doesn't matter which one. I'm going to have this one be my point that has an X that I know and a Y that I know. Or you could call, some people call it X1, Y1, X2, Y2. It really doesn't matter, but pick one, and that's the one you know. But what we don't know is the slope. So we have to go back to the first section and go use our formula to figure out the slope. So I've got my point in yellow, but I need to get my slope, and we'll do it in blue. So you should have learned in the first section that to do slope, you do y2 minus y1, 15 minus 10, over x2 minus x1. Be careful with those signs when you do -6 minus a -4. Again, be very careful with that you make sure you see that as being +4. Especially with slopes, those sign errors send you in the wrong direction. So it's actually really important. So I have a change in y of 5. And I have a change in x of -2. So my slope now that I'm going to use is -5/2. So now for my point slope form, I've got the yellow point and I have the blue slope. So what you do is you say, take that information and you do y minus the y you know, and again when you subtract a -4, you'll be adding 4, is equal to the slope we just found. And again, we talked today about in here about if it was parallel, you'd steal the slope. If it was perpendicular, you'd flip and go opposite. This one I had to go find the slope. So it's the slope times, y minus the y you know, which is the 10, I got a little sloppy there, is equal to the slope times x minus the x you know. And so I'm going to go color code this and do one more book problem. You guys just work on what you need to. I'm going to keep going with this recording though. So here's my yellow point going into the format of point slope form. And then the slope that I found is right here. Does that make sense, Leah? All right. So you also said number 36 was one of them, right? So those of you with bookwork, I'm also going to go hit number 36, so hang on. Again, if you have Delta Math, what I'm working on right now is your 2.4a topics. So it's from a day or two ago. Number 36, go ahead and read it to me, will you, kiddo? I think it said to graph, didn't it? I have my book open. Close it. Can you tell me what it says to, oh, here it is. It says to graph the line 3x plus 5y equals 12. So 3x plus 5y is equal to 12. Whenever you're asked to graph a line, you need to solve it for y. So regardless of how it's presenting itself, you need to go get y equals. So like we said, you need to always get rid of the x term by doing the opposite of what's there. And you either add or you subtract. And so because that's a positive 3x, we'll subtract it. Then I'll get 5y is equal to negative 3x plus 12. You could write 12 minus 3x, but like I said, I like to have it in the right order. Now for me to attack the y, you always divide by what's in the way. So I'll divide by 5. I'll divide by 5. I'll divide by 5. When I'm all done, I have y equals mx plus b. Unfortunately, they're not very pretty, so graphing it's not going to be particularly pretty, but that's okay. We'll just do our best with it. So I'll make a cheesy graph here. Again, it's y equals m. This is my slope. And this is my y-intercept. And we go deal with that y-intercept first. So what I do is I hop on my y-axis at 12 over 5. And 12/5 is 2.4 on a calculator, if you were to do it. So you're going to go up about to 2.4-ish. Again, we're sort of just estimating. But that's my y-intercept right here. That gets plotted. Am I going too fast, Leah, or am I good? Okay. So I've got my y-intercept. Then I'm going to take my slope in bright green here, and I'm going to put my finger on that point, on that y-intercept. I'm going to put my pen there, and I'm going to drop 3. 1, 2, 3, and run 5. 1, 2, 3, 4, 5. And again, I'm not on graph paper, but you get the general gist of it. Then you just connect the points. So again, you solve it for y, which I did in the yellow there. You'll get the y-intercept right here in blue. You put a dot there. Then you use the slope to do exactly what that slope tells you. Slope is rise over run, and when it's a negative, it's a fall over run. So I dropped my pen 1, 2, 3, and I moved it over 1, 2, 3, 4, 5 to the right. What do you think, kiddo? Do you want to try another one since we're here? What was after 36? Did you have to do 37 as well?
It goes through 45.
Okay, let's go try 37 since I'm already up here. Again, we're on the bookwork, page 87. But for those of you who don't have bookwork, we're kind of reviewing 2.4a right now. At the beginning, we were reviewing 2.4b with the parallel perpendicular lines. Okay, so 2.4a number 37 we're going to try. All right, so let's take a look at what we have. We have 2x plus y equals 3. And I said whenever you have to graph it, you have to solve it for the y. So we will solve it for the y. Right, Rhea? So what will I do to both sides? Yes, subtract the 2x, because you always start by adding or subtracting, and you do the opposite. Since that's a positive 2x, you subtract it. Now this one's kind of nice because there's nothing in front of that y that I need to divide out. Technically it's a 1, but usually we divide by what's in the way. There's nothing in the way, so it's done. Make sense? So now when we go graph it, I'm going to keep it color-coded like I did before. We will plot the y-intercept on the y-axis. Is this helpful, Lee?
Yeah.
So we'll go plot that right there. And then from there, I'm going to go do green again. I'll use this slope. And do you think I'll go up or down with my pencil? Since the slope is -2. I'm going to go down 2. When you don't see a denominator, it's a 1. So I'm going to drop my pen 2, and I might as well make a green pen, huh? So I'm going to drop it 2, 1, I tried to, 1, 2, and then I'll run 1 to the right. So I'll go 1 to the right. I'll connect these and move on to the next problem. All right? So that was a little help with 2.4b and then 2.4a. I did them out of order today. All right, then I'll help you guys just 1 second.